We've got two more related rates examples in this video. The first, this problem came up a couple years ago in the 2012 AB exam. We've got a 6-foot tall man walking away from a 24-foot tall lamppost at a rate of 5 miles per hour. At what rate is the shadow moving from the man when he's 20 feet from the pole? Okay, so my drawing. So I've got, I've mentioned before, I don't like to write in things that are changing quantities, but of course the height of the lamppost is 24, and the height of the man is 6. Okay. And it's beaming that shadow down like that. I'm going to name this length right here his distance from the lamp. I'm going to name Y. I'm going to name this distance, the distance the shadow is away from him, as Y. Excuse me, I'm going to name the length away from the lamppost X. Okay. So the rates, I only know one rate. I know that he's walking away, so dx dt is 5. And I'm looking for how fast the shadow's moving away from him. Like that. Now the equation for this one is a little bit tricky, and let me just kind of talk through. There are a lot of different things we know about triangles, but we can kind of rule them out. We don't care about the hypotenuse here. We haven't dealt with that. We don't need to, so we don't need Pythagorean theorem. We don't care about the area, so we don't need half base times height. We don't care about an angle at this point, so we don't need the trigonometric functions. So what we're left with, really, with triangles is similar and congruent triangles. And what happens here is these two triangles, this big triangle and this little triangle, are similar. Okay? So what we can do is set up a proportion that the big height is equal to the big height over the big base is equal to the little height over the little base. Okay, take a look at that. The big height is to the big base as the little height is to the little base. They need to be in proportion to each other. Okay, I'm going to cross multiply. 24 multiplied by y is 24y. 24 multiplied by 6x plus y is 6x plus 6y. I could do a little algebra here. I could subtract 6y from both sides and have 18y equals 6x. I could divide both sides by 18. I'd have y equals 1/3 of x. So now I do the derivative. Well, the derivative of y with respect to t, derivative of x with respect to t. Substitute and solve. dy dt is equal to 1/3 multiplied by 5, so 5/3 miles per hour. And that's my answer. It always throws people that the 20 feet that he is away from the pole doesn't enter into it, but it doesn't. It doesn't matter at all. Okay? So yeah, you need to use proportions because none of our other triangle formulas seem to fit the information we want and need. One other thing that could be asked here, you notice that this says how fast is the shadow moving away from the man. I could change this to be how far is it moving away from the lamp. Okay. In which case, I know the man's walking away at 5 miles per hour and the shadow's moving away at 5/3, so I could just add the two together to get how fast the shadow's moving away from the lamp. Okay, a water tank has the shape of an inverted circular cone with a base radius of 2 and a height of 4. The water is being pumped into the tank at a rate of 2 cubic meters per minute. Find the rate at which the water level is rising when the water is 3 meters deep. Okay, so let me draw my cone. Okay. So, again, I don't like to write in things that are changing, but I do know that the base radius is 2 and the total height is 4. and I'm filling this thing up with water. Okay. All right, so the rate that I know. Well, sometimes it's hard to know. You see that cubic meters, that's a volume, so I know the rate at which the volume is changing. And I want to know the rate at which the water level is rising. I'm going to call that height, because of course our cone formula is always in terms of height. I don't know why I just did this. Let me go back and write this as 2. Okay. So equation. We're going to need volume of a cone, 1/3 pi r squared h. Now, before we do the derivative of this, and believe me, you could at this point. You'll notice that if you did the derivative, you would need product rule because we've got 2 variables. So you'd have first times derivative of the second, r squared times dh dt, plus second, h times derivative of the first, so 2r dr dt. You could do that. The problem is we don't care about dr dt. It's asked how fast the height is changing. They gave us h, right? They told us h was 3, but they didn't tell us r. So we don't have r, we don't have dr dt. So we've got a lot of things that we don't know that we'd have to solve for. We have a way around product rule. Okay? I'm going to draw this right over here. Okay? This is the secret of the cone problem. It's called the cone ratio. Similar to the man walking away from a lamppost, we can set up a ratio where we say that the full cone, which has a ratio of 2 to 4, radius to height, has to be equal to the radius and height. It has to be in the same proportion at any point that the cone is filled to. So this is always just, radius and height, like this. Okay. So what I could do was I could just set this up and say 2 over 4 is equal to r over h. And I could multiply both sides by h. Of course, this is 1/2. So I end up with r equals 1/2 h. Okay. Now, I can take that ratio and put it back in to my volume equation. So instead of r squared, I'm going to write 1/2 h squared times h. Now again, if you're thinking, well, how did you know to do it that way? How did you replace it that way? I wanted to keep h. I'm looking for dh dt. So I needed to keep the h variable. I couldn't lose the r variable. And this ratio, I set this equal to nothing, and that's really just saying that the full cone, 2 to 4, will be equal to, no matter what we pick as the height. In our problem, the height is 3. So we could have set this equal to, the radius over 3. We could have calculated the radius. And then, as I said, if we had done the problem with product rule, we could have plugged everything in, and it would have been okay. But it just would have been a lot of extra work, because we can simplify this. Okay, 1/3 pi multiplied by 1/4 h cubed, because h squared times h. Okay, this becomes 1/12 pi h cubed. So as I do the derivative, dv dt is equal to 1/12 pi times 3h squared dh dt. I substitute what I know. So we have 2 equals 1/12 pi times 3 squared dh dt. Okay. So as we let me think about solving this, I suppose I could right away just maybe do a little bit of something like that. So I have 3 squared over 4, so 9/4. So I have 2 equals 9 pi over 4 dh dt. Okay, I could solve that by multiplying both sides by 4 over 9 pi. So my final answer is 8 over 9 pi meters per minute. Okay. Now let me go back here. The secret to this is always setting up a cone ratio. And I want to be very clear, this right here is what you should do. And of course it won't always be 2 and 4, but you should always set, whatever the full cone is, radius over height equals r over h, and solve. And the reason we did this was so that we could then replace one of the variables. I chose to replace the r because I needed h to stay in the problem. We were looking for dh dt, so it wouldn't have done me any good to eliminate h. On the other hand, if you cared about how the radius was changing, then obviously you'd want to solve for h equals, so you could replace h and just have r. But that is the secret, to always start this ratio and then use the ratio in the problem to clean it up, get it in terms of one variable. And it actually, of course, comes out to be a pretty nice equation. But you definitely want to do that. And as I said, if you did product rule, if right here you said, okay, I want to do product rule r squared dh dt plus h times 2r dr dt, you would still need this ratio to figure out what r was, and then you would still need this to figure out what dr dt is. You'll notice it's half of dh dt if you think about the derivative. So you're still going to end up doing the ratio, it's just that you had to do product rule first, and then get the ratio, then use the ratio to solve for everything. So it's a lot of extra steps if you could just do the ratio right away.